Hi, everybody. Welcome to today's live stream. We're so excited that you are joining us. We are going live all over the world. Today, we're going to be streaming across 4 different channels. So we're live on our Danfoss Cool channel on YouTube. We're also streaming to our YouTube channel in the United States. We're streaming on LinkedIn, and we're also streaming on Twitter today. So we're going to be having a great conversation, and we want you all to be a part of it. I can see that some of you are already checking in our chat. That's fantastic. It's great to see. I see someone's here joining us from Algeria already. So yeah, go ahead and put your country, where you're tuning in from, in the chat. We want to see where we're talking to as we have this live stream today. So I've got Anja and Mark with me. They've got a really exciting update about our Coolselector 2 software that they're going to be sharing about today. So we're going to be broadcasting for about 20 minutes or so. And again, the focus of this is conversation. We want to talk with you and we want to engage with you. So as they're sharing a little bit about Coolselector 2, please drop your questions, drop your comments in the chat. We'll be watching and they will do their best to answer all of them. I'm seeing even more countries coming through right now. We've got Florida in the US, we've got India, we've got London coming in. It's really great to see all these different countries. Global live stream again. So, all right, enough from me. I want to get on with the program. So, Anja, why don't you go ahead and introduce yourself and introduce Mark, and then let these people know why this live stream is so exciting.
Yes, thank you. Thank you, Lasse. So hello, everybody. I'm very happy to see that you guys are here from all over the world. My name is Anja. I'm working for Danfoss for 3 years as a launch manager and special focus on launching all our great new products in the CO2 world. Because in Danfoss, we have a slogan going on that is, we love CO2. And that is meant in the best way possible, that we love CO2 as a refrigerant because it is the best choice in our world. And that is the topic we will speak to you about today. First, I should go ahead and try to share my screen. So bear with me. I need to see how I do this. So I hope you all can see my screen right now. Because the reason why we are giving this introduction to all of you today is because we have a great solution that we want to share with you that is called the multi-ejector solution. And the reason why it is a great solution is that this solution is a game changer within refrigeration and CO2. Because if you want to do CO2 as a refrigeration, it is different possibilities depending on where you are around the world, as different things affect how well you can use CO2, which I will guide you through in a sec here. Our portfolio consists of different products. It is always, of course, the multi-ejector itself, which is the valve expansion device that actually do everything possible. And of course, it always consists of a pack controller that is like the brain controlling the heart of the system, you could say. In our multi-ejector solution, we have different variants. We have, this is a CTM6 blocks, we call it. So it's a block with 6 ejectors in. We could also have a model with 5 or 4, or even down to this little sweet baby here, where there is 1 or 2 ejectors in. But how do you find out what ejector is relevant for your area in the world? Let me take you through here. If you scroll down this page, you'll be able to see a very quick small guide here that we made, because it is actually quite simple. If you want to figure out what is the right multi-ejector solution for you, I have 3 questions for you. So first question is, where are you in the world? What is the ambient conditions you are working with? Because that has a huge impact to what kind of system you need to build to have CO2 being seen as a competitive refrigerant in your area. Because normally in very hot ambient conditions, CO2 was at some points outperformed by other refrigerants, but no more, because now we have, as we say in a nice way, we have eliminated the CO2 equator. So now CO2 is possible all around the world. So first consideration, what kind of ambient temperatures do you have? The second question I have is, what kind of CO2 systems do you work with? Because it's all about what kind of system you're familiar with and what kind of system you know how to operate and maintain. So if you are used to having a system with parallel compressions, meaning IT compressors, then that is one option. Another option could be that you are more familiar with having systems with only MT, and here we have one solution for you. Finally, we have a solution that can work in both booster or parallel compression. So have an answer for question number 2, then I will be able to give you a quick answer. The third question, that is, what kind of size of store are you working with? Are you working with a smaller shop with a cooling need of 40 kilowatt, or into a mini market, supermarket, or all the way up to a hypermarket with 300 kilowatt needs or more? That all depends on what kind of solution we would offer for you. So with those 3 simple questions, we can tell you what ejector solution will fit your need. We have the ejector solution up here. That is the high pressure ejector solution that is suitable for big supermarkets. We have the low pressure ejector solution here that works in systems where it's a booster and can be smaller systems. Then we have one of our newest introduced solutions that is quite a game changer, which is our liquid ejector, and introducing this concept of CALM, CO2 adaptive liquid management, meaning that you are able to work with liquid CO2 in your system. That is a whole other chapter we'll get to later. And then we have the combi block, where we are combining the best of high pressure and liquid into one, making it fit to a specific supermarket. And down here, you have the answer to everything I just asked as the 3 questions before. So depending on where you are in the world, what kind of system you like, what system size, and so on, then you will be able to see what actually fits your need.
It's really great, Anja, and I can see that that people are even sharing some of their ambient conditions in the chat there. Some from the UK and some from other parts in the world. So 28 degrees to 32 degrees Celsius, 0 degrees Fahrenheit to 99. So people are weighing in. And for all of you that are tuning in, if you like what Anja's talking about, if this makes sense to you, make sure to give her the thumbs up, hit the like button, the little heart button if you're tuning in from Twitter, which again, this is the first time today that we've ever live streamed on Twitter. So that's really exciting. Again, make sure that you're asking questions. Anja is here live, and so is Mark, and they want to answer any questions that they can about either the multi-ejector solution, or if you have questions about Coolselector and what we're going to cover today, just drop that in the chat. So Anja, was there anything else that you wanted to cover before we pass things over to Mark?
No, I just want to show, maybe here is an example.
There it is.
Yes, here is a little baby. This is my baby. This is the multi-ejector, and this is
and
a
you
cut
keep
model.
It right there on your desk, right? All the time.
Yes, I do. Yes, I do. And this is a particular one, because this is, of course, not the one you will get when you order it from our stock, but this is a cut model that we use for exhibitions and trainings, where you actually can see what's going on. Here we have the ejector itself. You can see what's going on inside. And over here we have the strainer that, of course, can be taken out and cleaned and making sure the ejector works perfectly. Awesome. But if you want to learn more about this and how it works, visit our website. But I think the most important part is actually what Mark is doing.
Yeah,
and
the website, right? multiejector.danfoss.com. I think we have a little graphic that we get. There it is. So yeah, head to that link. I think our chat moderators will also be dropping the live link into the chat, so you can just click on that. You can even see that graphic that Anja was just showing, and use all the data from there to inform yourself about the multi-ejector solution. So great, thanks for that, Anja. Mark, now we're going to go over to you. You have some really exciting news about what can be done with Coolselector. So maybe just share a really quick update for people if they don't know, what is Coolselector?
Okay, let's first start by sharing my screen. Well, Coolselector is our main selection tool we are using to select all components we are producing in Danfoss, all automatic controls, also compressors, also the condensing units. And within this really great tool, we develop a new application. I was in charge for this application, which I would like to share with you today. So first of all, okay, my name is Mark Siever. I'm global application expert and special focus on food retail. And mainly I'm focusing on the CO2 applications. Of course, in the food retail, there are other applications, but point of my interest is CO2. So we had and still have a possibility to select, as you can see here, different products. And especially today, I will focus on those products which are, let's say, dedicated for the CO2. For those who don't see this very clearly, so we will talk about transcritical high pressure valves, transcritical gas bypass valves, and multi-ejectors. So we had possibility to select these components as a single component, but I found it will be much better to analyze and select those components, let's say, running together. So for that reason, I developed this application, and this is under commercial applications. You can go here, and then if you press this area where this picture is, or the thumb, you will enter to this application, and the whole topic is about how to select those expansion valves for the gas bypass valve application, and also for the high pressure expansion application. And what was my aim during this process of development was to combine features what we have in the most advanced controller for the CO2 systems. It is AKPC782A, and those features which are possible, some of those features to combine together with selection of those expansion valves. I will briefly go now through the system configuration. What maybe you can have an idea how this system can be built. So you can select from the very basic transcritical system without any parallel compressors, without any ejectors. The system will be as a what we say very basic or standard system. But based on this one, you can go to the more advanced system. Of course, you can always, in every system, you can select, will you have a low temperature and medium temperature load? And on this system, you can add parallel compressors or high pressure ejector or liquid ejector. And then, of course, system will become a bit more complicated, as you can maybe observe there are much more components in this area here, but also there are more compressors and all this around the control. It's becoming a bit more advanced than a basic system. As a system which is a bit different from the previous ones is a low pressure ejector system. Is the system mainly for the smaller system because the way how this ejector, it's a different kind of ejector. It's capable to take all the flow from the medium temperature evaporators and deliver this to the receiver. Of course, this is a very simplified scheme. We will talk about more details next Tuesday. Concerning main logic in the system, we create different tabs. First two tabs are related to the dimensioning criteria. We have dimensioning criteria for gas bypass valve. On Tuesday, we will talk about why we have certain values here, why we are changing those values when you go to the next one, which is the high pressure valve and ejectors dimensioning criteria. So here you will have a different criteria, different when you have ejectors, when you don't have ejectors. And then as a third one, you will be lead to the operating conditions tab, where you will specify your system load, and then you will be able to observe how your components you dimensioned, you specified, you have it in your system, how they will operate at dimensioning criteria, but also at operating conditions, which is, of course, interesting to follow up.
Mark, before you continue, you've mentioned now Tuesday a couple of times. Do you want to let people know what's going to be happening on Tuesday?
Yes, of course. At the end of this presentation, I will, of course, go through the agenda and repeat once again that we will have 2 sessions. If we are talking about, let's say, European time. There will be one morning session and then one afternoon session. But of course, those colleagues who will join from different parts of the world, it will not be morning and evening, so it will be first and second session.
So we're going to be having a dedicated webinar where you can go in depth into and learn more about this feature. So we're on this live stream, we're just giving all of you who are tuned in a quick overview of what it's all about. And then next week, Tuesday, Mark will be hosting 2 separate webinar sessions, one in the morning and one in the evening in European time. So that way, people from all over the world, wherever you are, you can join in and participate and get a more in-depth look. And we'll be sharing the link to that webinar here in the chat, either now or a little later in the session. So I've got a quick question, Mark, if I can ask it to you before you continue on.
Yes.
Aldo asks, I want to learn more about the psychrometric diagram. Can you just mention quickly what that is all about?
Is it a log pH diagram we are using in refrigeration, or psychrometric, which is more for the humid air?
He's asking about the psychrometric.
Well, this is for the air. It's air diagram where you can see the temperatures and the relative humidity for the air. And we in refrigeration typically are not focusing on such diagrams. We are looking log pH diagram where I can show you later on.
Great.
At one, just as example. But
okay, so you're going to be looking at the log pH diagrams later in the presentation.
Yes, well, this is the basic, again, on the session on Tuesday, we will go through the different systems, explaining through the log pH diagrams, so it will be easier to follow up the system operation.
Sounds great. So Aldo, if you want to learn more about that stuff, please join the webinar next week.
Yes, super.
All right, Mark, why don't you go ahead with the rest of your presentation.
Depending on systems, we will go deeply in analysis. I will highlight some specific things. For example, in the parallel compressor system and the high pressure ejector, the system can look like this. So we could have a high pressure ejector mounted in parallel to the high pressure valve. And what is the beauty of this application, that now we are analyzing these 2 components in the system which are mounted in parallel, how they will be loaded depending what is coming from the gas cooler. But even more, we can also have 2 high pressure valves mounted in parallel, but also 2 gas bypass valves in parallel. And now we are coming to the system which is very often built, when we are talking about bigger systems, 200 to 300 kilowatts. So system will look very like this one. And now in just one row, you can specify your system and have all ready for your project. Concerning liquid ejectors, it's another ejector which is, let's say, completely different from the high pressure gas ejector, and the system and the logic is a bit different. But what is the beauty of this ejector? It can be applied to the standard booster system. I will explain in a very detailed way how this system should work, and I will mention a couple of times this brand name, what we have, CALM, or CO2 adaptive liquid management, so which consists of pack controller, system manager, which is a network unit, and also the evaporator controllers and how it should work. I will explain later on. But once again, what is the beauty of liquid ejector can be applied to the standard booster system, can be also added to the parallel compressor system, and at the end, of course, to the, let's say, very complicated system together with high pressure ejectors. So those ejectors can be running in parallel, and well, this is the most advanced technology what we can offer today.
Great. Mark, can I jump in again with another
Yes.
question from our audience? So Mohammed has asked, can CO2 be used in high ambient temperatures?
Very good question. When CO2 started 15 years ago as a technology, first it started in the countries, let's say, on the north of Europe, north of America, and other countries, because at that time we were having a system what we call today's standard booster system, and the consequence of this system is that during summertime you have a lot of gas fraction in the receiver. You have to bypass through this gas bypass valve, and then you have let's say work loss, because the gas is circulating, doing nothing at the end. And since that time different technologies were developed. One of technology which can increase efficiency of the system, technology which was introduced to the market like 10 years ago, at least from Danfoss. We had the first version of parallel compressors, so it increased efficiency of such a system in a warmer climate. Adding ejectors, it's moving ahead this improving efficiency of the system, and today we can say that we can build such a systems in hot climate areas with same, and I can say also even better efficiency of equivalent HFC system. Of course, question is what is the reference, how you are analyzing let's say existing HFC system to, let's say, for example, this advanced system. So all in all, as a conclusion, yes, of course, we can build today such a systems, and they are already built in really warm climate. For example, Middle East, we have a couple of installations already there.
Great. Thanks for the answer. I got another question from Stefan. What rate are the injectors running at?
What rate?
Yes.
I don't understand the question.
Maybe a question for you, Anja. Is that something that you can address? No? Okay.
No, that's not a term we know.
Stefan, if you can try to add a little more context to the question, then maybe we can come back to it.
Maybe entrainment ratio, something like this, or if we are talking about entrainment ratio, then we have different ejectors, as you can notice from the previous different systems. So, for example, we have a HP high pressure lift ejector, which can produce higher pressure lift, but by doing this, the entrainment ratio is lower. And typically we are tuning to have this ratio between 0.2 and 0.25. Okay. If we are talking about low pressure lift ejectors, which are a different kind of gas ejectors, here this ejector can produce a lower pressure lift, but it has a high entrainment ratio, so he can pull a lot of mass flow and lift it from the medium temperature evaporator, bring it to the receiver. So it's a different construction of the ejector. And then on the third side, we have a liquid ejector, which is specially designed to work like a pump at the end, so to lift liquid. So it has also different characteristics, of course.
Great. Thanks everyone for asking those great questions. Mark, why don't you keep going, and we'll get to some more questions and comments a little later.
So just a brief information about what you can also find within this Coolselector, and particularly this application within the Coolselector is this PI diagram, then a log pH diagram, and this is what I mentioned before. So you will have for every system this chart drawn in let's say, real log pH diagram, so it can be also part of your report at the end. You will have all information about your cycle results, different calculations of COP, also capacities, mass flows, etc. And what is the beauty of this? You can do also export this data to your Excel, and then if you would like, you can do your own analysis based on this data at different operating conditions, of course. And at the end, you can very easily make your report and add to your project design specification. And well, agenda, I mentioned 2, 3, 4 times this training for the Tuesday time. So we will go through these systems, what I just briefly touched today. We will go a little bit deeper inside what is specific for such a system and how this is reflected to your selection in the Coolselector. And then at the end, of course, I will do a live selection in the Coolselector, so then we can go back and forth and to see how this will be, how results will change during this process of configuration. And well, at the end, I'm inviting you to join these sessions. So this time here is Central European time. But I hope now my colleagues, if not yet, they will share these links in the chat area.
So we've got the link up here on the screen, and then definitely for the webinars, our chat moderators are going to be sharing the link where you can sign up for next Tuesday, and that's going to be a really great time. Again, there are 2 opportunities to join, so register for that. It looks like we've got another question here from Eduardo, yes. Where he asks, how do you calculate optimal gas cooler pressure in Coolselector? Mark, I don't know if that's something that can be done on the live stream, but...
No, it's a valid question. So a long time ago, this optimal COP line was calculated. And we in Danfoss have our own formula how we are calculating this. If you are familiar with our documentation, I mean, for example, PEC controllers, then in every PEC controller, which is for the CO2, you will have this explanation how this curve look like. And also, I will briefly also mention on the coming training how it looks and how it is visible in the Coolselector, because also this formula is of course behind the Coolselector, and you have possibility to work in your own pressure, temperature specification, or you can run on this optimal COP line. So yes, good.
Great. All right. So that's about all the time. We've actually gone a little bit over time today, which is great though, because there were so many awesome questions. And so I just want to say thank you first to Anja, and then also to you, Mark, for sharing a little bit about Coolselector and about our multi-ejector solution. And just to all of you who tuned in for the live stream, thanks for taking the time to be with us. And thanks for engaging with us in conversation in all the different platforms, Twitter, YouTube, LinkedIn. And definitely please sign up for the webinars next week. And of course, if you have any questions that we didn't get around to, or if you have questions after the live stream, please drop them either in the YouTube chat or in the LinkedIn chat. We'll be going through them and we can follow up with you after the fact as well. So we're not only available on live streams, we're available as often as we can make ourselves. So please download Coolselector, sign up for the webinar, and we'll see you on the next live stream.